Hey y'all, welcome to a new episode of Aftermath. Today we're going to be talking about the addition of rational expressions. Now if you notice here on the board, we wouldn't exactly call these rational expressions, we would call these basic fractions. I wrote those on the board because we're going to start off with those just to remind us of what the procedure is when we add fractions. The ones I have written up here are 1 over 11 plus 2 over 11. So 1/11 plus 2/11. Now that's easy addition to do because as we learned long ago, to add fractions, as long as we have a common denominator, we just keep that same denominator, 11, and what we do, since it's 1 plus 2, that's what our numerator is. Our numerator is 1 plus 2, and we know that 1 plus 2 is 3. So if we wanted to add 1/11 plus 2/11, we could write it as either 1 plus 2 over 11, or we could write it as 3 over 11. Now, if you're in my algebra class, this is lesson 44 in our books. Like I said, we're starting off with something simple right here. We're going to go ahead and look at some rational expressions that have a common denominator, and we're going to see that we can add them in the exact same way. Then we're going to go ahead and look at some rational expressions that have different denominators, and we're going to find out how to do those. Let's look. All right, so here we've got a rational expression on the board. Now remember, we call it a rational expression, not really because it has so much to do with rational numbers or irrational numbers, but because it's a ratio of two things. Remember, a ratio is another way of saying a fraction. They're very similar. They can be kind of considered the same thing. A ratio can be written as a fraction. So these are called rational expressions, and if you'll notice, if we treat them like fractions, just like in the simple fractions we just had, they all have the exact same denominator. They all have a plus 6 as a denominator. Now, that's very good for us because it means that we can easily add them like it's asking us to do. Just like we did in our example before when we did 1/11 plus 2/11 equals 3/11. We can do this the same way. So, if we were to add these three things, we're going to end up with another fraction, another rational expression. It's going to have the same denominator the old one did, a plus 6. And for the numerator, we're just going to add what was already there. That means we're going to have 5 plus a plus b plus 2. So that's what we're going to write for our numerator. 5 plus a plus b plus 2. Now, if you'll notice, in that numerator, we can't add everything. Remember, we can only add like terms. We can't add a and b, and we can't add 5 to a or b. But we do have 5 and 2 that are both like terms, so we can add them, and we should do that for our answer. We should add 5 plus 2 and get 7. We should still have a, we should still have plus b, and remember that our denominator will remain the same, a plus 6. All right, we're going to go ahead and look at one more example like this. All right, so here's our second example. Once again, we've got two rational expressions. You'll notice that once again, they both have the same denominator. So again, it's going to be easy to combine them. We're going to have an answer that has the same denominator in it, 5a squared x. And then for the numerator, we're going to combine everything that's up top. Now we have to be careful on this one. Our other example, we were adding the two numerators. This one we're subtracting, and that's going to make a slight difference. Watch. We have 5x plus 7. That's going to be part of our answer. But then, since we're subtracting this second numerator, this subtraction sign actually applies to both parts of it. So that means we have minus 3x, and it means we also have minus negative 2, or minus minus 2. And anytime we have two negative signs like that, two minus signs, they cancel out, and they become a positive plus. So minus minus 2 is really plus 2. So that's one thing you really need to be careful for. When you're subtracting the numerator, remember that subtraction applies to both parts of it. Now, just like we did on our other example, we should combine the like terms. We have 5x minus 3x, that equals 2x. And we have positive 7 plus 2, and that equals positive 9, plus 9. Still over our same denominator, 5a squared x. Now, these were pretty simple ones right here because they already had a common denominator for us. But we know from when we first started learning fractions that our math problems are never so kind as that. They don't usually give us the same denominator. So we're going to go ahead and look at some rational expressions that have different denominators, and what we're going to do is change them so that they do have a common one. Okay, now just as a reminder, we looked at a simple fraction before just to remind us how fractions work. Let's look at a couple fractions that have different denominators so we can remember how that works. Let's look at 1/4 plus 1/3. Now, we know we can't add those in the form that they're in because they don't have the same denominator. We need a common denominator. And the common denominator we use is actually the least common multiple of the two denominators. Good thing we just had a lesson on that, right? So, we want the least common multiple of 4 and 3, which in this case is going to be 12. We want to change each one to a denominator of 12. Now, to change 4 to 12, it means we're going to multiply it by 3. Here's the thing. We can't just multiply our denominator by 3. We have to multiply the denominator and numerator by 3. Now, the reason that works is because when we multiply by 3/3, we're really just multiplying by 1. 3/3 is 1. And if I multiply a number by 1, I haven't changed its value. I may change the way it looks, but its value remains the same. So, we get a new fraction here. We get 3/12. We're going to do the same thing over here, except to change the denominator of 3 to 12, I need to multiply it by 4. That means that fraction gets multiplied by 4/4. Once again, I'm really just multiplying by 1, so I'm not changing its value, just its form. So this time I'm going to get 4/12. And if I were to add these two fractions now, since they have a common denominator, I get 7/12. And that will work. We've got a common denominator now, so we get a good answer. Now we're going to see how it works with a rational expression. We're adding rational expressions that don't have the same denominator. In order for us to do that, we need to change them so that they do have the same denominator. So think about what we just did with the simple fraction. We found a common denominator. We're going to do the exact same thing. We have a denominator of 4 and a denominator of b. What we want to do is just put them together into a new denominator. 4b. That's what our new denominator is going to be. So, think about it. In order to change this denominator to 4b, what does it need? It's got 4. It needs b. And just like before, we're okay multiplying our fraction as long as we multiply it by 1, because then we don't really change it. So that means we're going to multiply it by b over b, because anything over itself is 1. We're really just multiplying it by 1. And for this fraction, we've got b, the part we're missing is 4. So we need to multiply this fraction by 4 over 4. Alright, so here's the new fractions we're going to get. We're going to get 3b over 4b. And we're going to get 2 times 4, 8 over 4b. Remember, you could call it b4. The order doesn't matter, but the correct way to write it is with the coefficient at front. So we're going to write it as 4b. And now we're going to combine them together into one fraction for our answer. Common denominator is 4b. Our numerator, they're not like terms, so we can't add them, but we can write it as an addition problem. 3b plus 8. That's our numerator. 3b plus 8. And there's our answer. 3b plus 8 over 4b. All right, that was a pretty simple one. We're going to look at one more example of a more complex one, and then we'll be done. Let's go ahead. All right, y'all, here's our last example. It's a lot more complicated, but we're going to do it the same way. We've got different denominators. What we need to do is find our common denominator. So start with the coefficients. This one doesn't have one, so we're not worried about it. Then we've got 4 and 3. We've already said today that when we have 4 and 3, our least common multiple, in this case our least common denominator, is going to be 12. Alright? Now, we also have c to the third, c to the fourth, and c squared. What we want is the least common multiple of those. If you'll remember least common multiple, you take the factor the most number of times it occurs. The most number of times C is used as a factor is right here, 4 times. C times C times C times C. So that's going to be our greatest common factor, which means it is also going to be, our least common multiple, which means it's also going to be our common denominator. So 12c to the 4th is what we want to use. And what I'm going to do is I'm going to kind of skip that second step we did on the last problem, and we're just going to look at each one, and we're going to go ahead and write it as one fraction for our answer. So this first denominator was c squared. We want it to be 12c to the 4th. So that means it needs 12, and it also needs an extra c squared in order to be c to the 4th. So we want to multiply it by 12c squared, and we also want to multiply the top by 12c squared. That gives us 12ac squared plus, then we look at this next denominator. We've got 4c cubed. I need to multiply 4 by 3, so that's going to be part of what we're multiplying by. And I also need to multiply it by c. So I need to multiply this denominator by 3c. I'll also multiply this denominator by 3c for a total of 9c. And then plus. And this one is very close. We've got 3c to the 4th. What we need to do is multiply it by 4 to get our common denominator. And so I'll also multiply this by 4. That will give me 4m. And now I've got our answer. 12ac squared plus 9c plus 4m all over the common denominator of 12c to the 4th. Now, like I said, I kind of skipped a step in there. You may want to leave that step in. It may be easier for you to write it all out. It's a little bit more writing, but it's better to do that and get the right answer. So whatever you're more comfortable with, that's the way you should do it. Now, if you have any questions, as always, you can hit me up in the comments. I hope that you'll subscribe to the channel, and I look forward to seeing you on the next episode.